Welcome back. In our journey through AI operations, we've explored the intricacies of AI solution development, the critical importance of data management, and the human-centric challenges of change management specific to AI. Now we turn our attention to the individual who stands at the confluence of these domains, the integrated AI professional. This chapter, structured around a set of core competencies, delves into the practical application of the governance, operational, and auditing principles we've been discussing. Our focus will be on a series of crucial tasks, predominantly centered around the act of evaluation, which underscores the critical assessment, informed judgment, and deep understanding expected of such a professional. The competencies we'll explore are not performed in a vacuum. They are deeply rooted in and informed by established global frameworks and standards. Throughout our discussion, we will see how the NIST AI Risk Management Framework, AI RMF, a comprehensive suite of ISO IEC standards, including ISO IEC 42001 for AI management systems, ISO IEC 23894 for AI risk management, ISO IEC TR 224028 on trustworthiness, and ISO IEC 42005 for AI system impact assessment, along with invaluable guidance from professional bodies like ISACA and the IAIA Institute of Internal Auditors, provide the bedrock for these evaluations. So let's embark on understanding the multifaceted role and the essential evaluation tasks that define the integrated AI professional, ensuring that AI is not only innovative but also responsible, ethical, and aligned with organizational and societal values. Segment 1: AI's role in audit and strategic organizational advisory. The integrated AI professional often plays a dual role, leveraging AI to enhance traditional processes like audit and advising the broader organization on the strategic implications of AI adoption. Task: evaluate impacts, opportunities, and risk when integrating AI solutions within the audit process. This involves a critical assessment of how AI tools can transform the audit function itself. The professional must look beyond mere efficiency gains. What are the opportunities? Perhaps AI can enable 100% transaction testing, identify subtle anomalies missed by human auditors, or provide deeper insights into risk patterns. What are the impacts? This could mean changes to audit methodologies, the skills required by audit teams, and the nature of audit evidence. And what are the risks? These might include over-reliance on AI tools, the black box nature of some AI making it difficult to understand its reasoning, or the risk of AI tools themselves being flawed or biased. Guidance from the AAIA on AI in auditing is paramount here, emphasizing a balanced view of AI's potential and its pitfalls within the audit. Context 1. Task: utilize AI solutions to enhance audit processes, including planning, execution, and reporting. This moves from evaluation to practical application. The professional is expected to be proficient in identifying and using AI tools to make audit processes more effective and efficient. During planning, AI might help in risk assessment by analyzing vast datasets to identify high-risk areas. In execution, AI can automate repetitive testing procedures or assist in forensic investigations. In reporting, AI could help visualize complex findings or even draft initial report sections. This requires not just technical understanding but also a deep knowledge of audit processes to ensure AI is applied appropriately and enhances rather than compromises audit quality. Task: evaluate AI solutions to advise on impact, opportunities, and risk to the organization. Stepping outside the audit function, the integrated AI professional acts as a strategic advisor to the wider organization. When the business considers adopting new AI solutions for various functions, e.g., the customer service, marketing, operations, this professional evaluates these proposed solutions. The evaluation covers the potential positive impacts, such as new revenue streams, improved customer satisfaction, operational efficiencies, the strategic opportunities AI might unlock, and the inherent risks, e.g., financial investment, ethical concerns, data security, vendor lock-in. This advisory role is crucial for informed decision-making at a strategic level, aligning with ISACA's focus on ensuring IT and AI governance supports business objectives and manages enterprise risk. Segment 2: assessing the broader impacts of AI systems. AI systems do not operate in isolation. Their influence extends to other systems, the environment, and most importantly, human lives and societal structures. Task: evaluate the impact of AI solutions on system interactions, environment, and humans. This competency requires a holistic socio-technical perspective. System interactions. How does a new AI solution interact with existing legacy systems? Does it create new dependencies or vulnerabilities? Are there interoperability challenges? Environment. While not always the primary focus, some large-scale AI models have significant energy consumption. This task might involve evaluating the environmental footprint of AI solutions, especially in organizations with strong sustainability commitments. Humans. This is a critical area. The professional evaluates how AI impacts employees, job roles, skills, morale, as discussed in our change management chapter, customers, experience, fairness, privacy, and other stakeholders. This involves considering usability, accessibility, and the potential for AI to cause undue stress or harm. The principles of ISO IEC 42005 on AI system impact assessment are directly relevant here, guiding a structured approach to understanding these broader consequences. The NIST AI RMF also strongly emphasizes understanding and managing the negative impacts of AI on individuals and society. Task: evaluate the role and impact of AI decision-making systems on the organization and stakeholders. Many AI systems are designed to make or support decisions, some with significant consequences. This task involves scrutinizing these AI decision-making systems. What is the extent of their autonomy? How are their decisions explained and justified? What is the impact of these AI-driven decisions on organizational strategy, operational efficiency, legal liability, and stakeholder trust? For example, an AI system used for credit scoring or medical diagnosis has profound impacts. The professional must evaluate whether these systems operate fairly, transparently, and accountably, aligning with the trustworthiness characteristics outlined in ISO IEC TR 240281. Segment 3: Ensuring robust AI governance, policies, and ownership. Effective AI adoption hinges on a solid foundation of governance, clear policies, and unambiguous ownership. Task: evaluate the organization's AI policies and procedures, including compliance with legal and regulatory requirements. The professional assesses whether the organization has developed and implemented comprehensive AI policies and procedures. Are these policies clear, practical, and aligned with the organization's ethical principles and strategic objectives? Crucially, this evaluation also involves verifying compliance with a complex and evolving landscape of legal and regulatory requirements related to AI, such as data privacy laws, e.g., GDPR, anti-discrimination laws, and emerging AI-specific regulations. ISO IEC 42001, the AI Management System Standard, provides a framework for establishing such policies and ensuring compliance. Task: evaluate the monitoring and reporting of metrics, e.g., KPIs, KRIs, specific to AI. What gets measured gets managed. This task involves evaluating how the organization monitors the performance, risk, and impact of its AI systems. Are relevant key performance indicators, KPIs, and key risk indicators, KRIs, defined for AI? Examples might include model accuracy, drift metrics, fairness metrics, security incident rates related to AI, and user satisfaction. The professional assesses whether these metrics are appropriate, accurately collected, effectively reported to relevant stakeholders, and used to drive continuous improvement and risk mitigation. The measure function of the NIST AI RMF provides extensive guidance on developing and using such metrics. Task: evaluate whether the organization has defined ownership of AI-related risk, controls, procedures, decisions, and standards. Clear accountability is fundamental to good governance. The professional evaluates whether the organization has clearly assigned ownership for all critical aspects of its AI ecosystem. Who is responsible for managing specific AI risks? Who owns the AI controls? Who is accountable for AI-driven decisions, especially when they go wrong? Who sets and maintains AI standards? Lack of clear ownership can lead to gaps in oversight and accountability. Isaka's COBIT framework strongly emphasizes the importance of defined roles and responsibilities for effective governance of information and technology, which extends directly to AI. ISO IEC 42001 also requires defined roles and responsibilities within the AI management system. Segment 4: Upholding data and privacy. Governance in AI data is the lifeblood of AI, and with data comes significant responsibilities regarding its governance and the privacy of individuals. Task: evaluate the organization's data governance program specific to AI. AI systems are uniquely dependent on the quality, integrity, and appropriateness of data. This task involves evaluating the organization's data governance framework as it applies to AI. Key aspects to assess include Data quality. Are there processes to ensure data used for training and operating AI is accurate, complete, timely, and relevant? Data lineage. Provenance. Can the origin and transformation history of data be traced? Bias detection and mitigation. Are there mechanisms to identify and address biases in data sets that could lead to unfair AI outcomes? Data security and access control. How is AI-related data protected? ISACA provides extensive resources on data governance, and these principles are critically important for AI 6. ISO IEC 42001 also has specific controls related to data for AI systems. Task: evaluate the organization's privacy program specific to AI. AI often processes vast amounts of data, including personal and sensitive information, raising significant privacy concerns. The professional evaluates the organization's privacy program in the context of AI. This includes assessing compliance with privacy regulations, adherence to laws like GDPR, CCPA, etc. Privacy by design are privacy considerations embedded into the AI lifecycle from the start. Data minimization is only necessary data collected and retained. Anonymization, pseudonymization are appropriate techniques used to protect identities. Transparency and consent. Are individuals informed about how their data is used by AI, and is consent obtained where required? The NIST privacy framework offers valuable guidance, and principles from standards like ISO IEC 3771 Privacy Information Management System are highly relevant. Segment 5. Assessing operational readiness and resilience for AI. For AI to deliver value reliably and securely, various operational programs must be robust and adapted to AI's unique characteristics. Task: evaluate the organization's problem and incident management programs specific to AI. When AI systems malfunction, produce unexpected outputs, or are involved in security incidents, how does the organization respond? This task involves evaluating the problem and incident management processes. Are they equipped to handle AI-specific issues, which might be more complex to diagnose, e.g. due to model opacity, or have broader impacts? Are escalation paths clear? Are lessons learned fed back into the AI development and risk management processes? Task: evaluate the organization's change management program specific to AI. As we discussed in the previous chapter, AI introduces significant organizational change. The professional evaluates the effectiveness of the change management program in supporting AI adoption. Does it adequately address employee concerns, provide necessary training, foster buy-in, and manage resistance? Task: evaluate the organization's configuration management program specific to AI. AI systems consist of models, data, code, and infrastructure components, all of which have configurations that can change. Robust configuration management is vital for reproducibility, traceability, and stability. The professional evaluates whether changes to AI system configurations are properly controlled, documented, and tested to prevent unintended consequences. Task: evaluate the organization's threat and vulnerability management program specific to AI. AI systems introduce new attack surfaces and are susceptible to unique threats like adversarial attacks, data poisoning, and model evasion. This task involves evaluating whether the organization's threat and vulnerability management programs have been adapted to address these AI-specific risks. Are AI systems regularly scanned for vulnerabilities? Are threat intelligence feeds monitored for AI-related threats? The NIST Cybersecurity Framework, CSF, provides a solid foundation which needs to be extended with AI-specific considerations. Task: evaluate the organization's identity and access management IAM program specific to AI. Who has access to AI models, training data, development environments, and operational AI systems? The professional evaluates the IAM program to ensure that access controls are appropriate, the principle of least privilege is applied, and identities are securely managed for both human users and AI agent systems themselves. Task: evaluate vendors and supply chain management programs specific to AI solutions. Organizations often rely on third-party vendors for AI tools, platforms, models, or data. This introduces supply chain risks. The professional evaluates the vendor due diligence and supply chain risk management programs. Are vendors assessed for their security, privacy, and ethical AI practices? Are contractual agreements clear regarding data ownership, liability, and security responsibilities? NIST SP 800-161, Supply Chain Risk Management Practices, offers relevant guidance. Segment 6, Ensuring Technical and Process Assurance for AI Systems. This group of tasks focuses on the integrity of the AI systems themselves and the processes used to create and manage them. Task: evaluate the design and effectiveness of controls specific to AI. Controls are the safeguards put in place to mitigate risks. The professional evaluates whether the organization has designed and implemented effective controls tailored to AI specific risks. These could be technical controls, e.g., input validation for models, access controls for data, process controls, e.g., review and approval for model changes, or governance controls, e.g., ethics committee oversight. ISO IEC 42001 Annex A provides a list of potential AI controls and frameworks like COBIT help in designing control environments. Task: evaluate data input requirements for AI models, e.g., data appropriateness, bias, privacy. Garbage in, garbage out is especially true for AI. This task involves a deep dive into the data used to train and operate AI models. Is the data appropriate for the intended purpose? Is it of sufficient quality and quantity? Crucially, has the data been assessed for potential biases that could lead to discriminatory outcomes? Are privacy requirements for input data being met? This links back to data governance but focuses specifically on the model input stage. Task: evaluate system plus business requirements for AI solutions to ensure alignment with enterprise architecture. AI solutions should not be developed in a silo. They must align with the organization's overall enterprise architecture and business requirements. The professional evaluates whether the requirements for AI solutions are clearly defined, well understood, and consistent with existing systems, data architectures, technology standards, and strategic business goals. Task: evaluate the AI solution lifecycle, e.g., design, development, deployment, monitoring, and decommissioning, and inputs, outputs for compliance and risk. This is an end-to-end evaluation of the entire AI SDLC as discussed in a previous chapter. The professional assesses each phase for adherence to policies, procedures, regulatory requirements, and effective risk management. Are inputs into each phase, e.g., data requirements, appropriate? Are outputs, e.g., trained models, deployed systems, monitoring reports, meeting expectations and compliance obligations? The NIST AI RMF, Map, Measure, Manage Functions, and ISO IEC 42001 provide comprehensive frameworks for this lifecycle evaluation. Task: evaluate algorithms and models to ensure AI solutions are aligned to business objectives, policies, and procedures. This task focuses on the AI models and algorithms themselves. Are the chosen algorithms suitable for the business problem? Do the trained models actually help achieve the defined business objectives? Do they operate in accordance with organizational policies, e.g., ethical guidelines and procedures? This might involve assessing model performance, interpretability where needed, and robustness. Segment 7: cultivating an AI-ready workforce and organizational awareness. The human element remains central to successful and responsible AI. Task: analyze the impact of AI on the workforce to advise stakeholders on how to address AI-related workforce impacts, training, and education. This competency involves understanding how AI adoption affects employees, their roles, skill requirements, and career paths. The professional analyzes these impacts and advises leadership and HR on strategies to manage the transition. This includes identifying skill gaps, recommending training and education programs, and suggesting ways to support employees through AI-driven changes. This directly connects to the principles of AI-specific change management. Task: evaluate that awareness programs align to the organization's AI-related policies and procedures. General awareness about AI, its capabilities, its limitations, and the organization's policies regarding its use is crucial for all employees. The professional evaluates the effectiveness of AI awareness programs. Do they accurately reflect organizational policies? Are they reaching the target audience? Are they helping to foster a culture of responsible AI use and vigilance against AI-related risks? ISO IEC 42001 emphasizes the importance of awareness and competence. Segment 8: conclusion, the evaluative heart of responsible AI. The diverse array of evaluation tasks we've explored paints a clear picture of the integrated AI professional, a knowledgeable, discerning, and ethically minded individual crucial for navigating the complexities of artificial intelligence. Their ability to critically assess impacts, opportunities, risks, policies, programs, and the AI systems themselves is fundamental to ensuring that AI is developed, deployed, and governed responsibly. These competencies are not static. The field of AI is in constant flux. Therefore, a commitment to continuous learning, staying abreast of evolving technologies, emerging risks, new standards, and shifting societal expectations is an intrinsic part of this professional's journey. By mastering these evaluative skills, grounded in robust frameworks from NIST, ISO, ISACA, and the IAA, the integrated AI professional plays an indispensable role in helping organizations harness the transformative power of AI while upholding ethical principles, ensuring compliance, and building a future where AI serves humanity effectively and equitably. Thank you for watching, and as always, continue learning, stay curious, and we'll see you next course.